Alright, hello. Welcome to this lesson of our study of vectors. Alright, so in this lesson we'll go through the internal and external division of two position vectors, how a third point can divide it, okay? So if you have not subscribed to the channel, kindly subscribe to support the channel. Thank you if you have also subscribed as well. Let us all help to grow the channel. Okay. So let's start. I said we'll deal with internal and external, okay? So first, let's take the internal division. Alright, let two position vectors OP and OQ, like I have here, okay, OP and OQ be given, and let a third position vector, which is the OR, divide PQ, the line segment PQ, okay? This is very important. Internally, in the ratio M is to N. This is also very internal, this is also very important. You see, the line segment that this third point is dividing through is PQ. This is very important. The direction of the arrows are very, very important. It can be QP. That will be a different case, okay? So when you're dealing with vectors, your directions should be very, very important. Okay, then the following holds. Okay, so we are going to discuss about something that if these scenarios are what we discuss, and then what I'm coming to explain here, or the diagram you are coming to draw here, really holds. Okay, so let's look at the diagram and see. Okay, so we're saying that position vectors are OP and OQ, and then the other vector is also OR. I mean, they are all starting from a common point. Okay, so let me say this is the this is how the diagram should look like. Okay, let me have this. Okay, and let's say this is a third side. I don't know the magnitude of N and M, so let me put it anywhere. Okay, so that we just go ahead and do. So this is O, because they are all starting from O. So let's say O is there, is this place, and this OQ, this is OP, and since we're giving OP, means this is how the directions are, and OR is also like this, and this is R. And we are saying that the point R is dividing PQ, meaning the direction for this side is this PQ. This is how it's moving. It's like the direction is from Q to P. Okay, so this is how it moves, and then it's dividing it in the ratio M is to N. Okay, so the M will be for the P side, because it's dividing PQ. Okay, so from P to Q, like this. Okay, so that is why you put the M that's that at that part. Okay, like this. So this is a scenario, this is a diagram for whatever that is happening there. And so from this diagram we can see a whole lot of things. Okay, so from the diagram, let's put it here somewhere. From the diagram, okay, or from the triangle, let's say triangle, anyhow you want to put it. Okay, from the diagram, okay, what can we see? All right, so the things we can say is that if you pick vector PR, okay, meaning from this point to this point, okay, from P to R. So if you pick PR like this and divide it by RQ, or let's say QR, or RQ, let's put it that way, because R is moving to Q. So RQ like this, then you give us the fraction of the ratios. I hope you get it. So this is how the thing look like. Okay, now with this, let's go ahead and find PR and RQ, okay, from our triangles. Okay, we have a whole lot of triangles here. Okay, so let's keep this somewhere, and then from triangle ORQ, O is here, R is here, and Q is R is here and Q is here. So I can draw that triangle. Okay, I hope you can see. So let's try to figure that triangle out and see how it looks like. Okay, so the triangle is like this, this and this. Okay, it's just this. Okay, so I have my O here, my Q here, and my R is here. Okay, and this. Okay, let me put it here. This is how the arrows look like. I have it here, and I have this one here. I have this one also going that way. So from this triangle, what can we say? We can say that from the triangle of vector addition, the ones that are moving in the same direction. Okay, so you can see that OR is moving here, and RQ is also continuing like that. Okay, so their sum will be equal to the one that is moving the counter direction. Okay, that's why we just discussed in addition of vectors in the triangle of vector addition. So OR, okay, plus RQ should be equal to OQ. Okay, and from position vectors, we can name the RQ and then OQ and the rest. You can say OQ is small q. Okay, OP is small p. Let me put them there, and OR is small r. Okay, so it means that this RQ here, I want to make, there is an RQ in this. Okay, so I want to make RQ the subject in this one. So you can say that RQ in what I've just written here is equal to OQ minus OR. Okay, and this is the same as small q minus small r. Okay, so we keep this and go ahead and find from triangle OPR. Okay, sorry, OPR. Okay, so let's go ahead and look at triangle OPR. This is triangle OPR. This is O, this is P, and this is R. Okay, so I can draw that triangle as well. Okay, so we can take a pen and pencil and draw that triangle and see. That triangle looks like this. Okay, let me draw it well for you. Or let me, okay, it looks like this. Let's draw it like this. Okay, so that is it. O P R. Okay, so O is here, P is here, and R is here, and this is how the directions are. Okay, and this one is moving to that direction. With that one too, we can say that OP plus PR, okay, is equal to OR. I hope you can see this. Now we know that PR is also equal to OR minus OP, which is the same as small r minus small p. Okay, so go ahead and with the equation that we wrote, we said that, let me write it here back. We said PR, okay, over RQ should be the ratio or the fraction m over n. And now we know PR, we know RQ. Okay, if you remember, this is our RQ. RQ is Q minus R, this one, and our PR is also this. Okay, so you put them in the this equation there, and then this is what you get. We get PR is what, R, small r minus small p over this QR, and that is small q minus small r, and is equal to m over n. Okay, so simply what we want to do is we want to find the third position vector that divides this. Okay, so you want to find the formula for this, because always OQ and OP will be given. So what we want to do is want to find a OR. Okay, so the OR will give us the small r, obviously, and so it means that I have my n into bracket r minus p is equal to m into q minus r. Okay, so with this, nr minus np will be equal to mq, okay, minus mr. Now with this one, you want to make r the subject, so quickly let me write it here. You have nr minus np is equal to mq, okay, minus mr. So we put all the r at one place like this, should be equal to mq plus np. So I have my r out, m plus n, or you can say n plus m, anyhow you want to say it. This plus np. This means that r will be equal to mq plus np all over m plus n. So the position vector for the point that divides the line segment PQ. So look at how the segment is like PQ. Okay, so it's from P to Q. Then it means, and it divides it in the ratio m is to n. So always you take the first ratio, multiply it to the last one, that is the Q. Okay, so it's like this. Then plus the last ratio, multiply the first vector, which is the P, over the summation of the ratios. Okay, I hope you get it. So always check your directions very, very well. Okay, we can say that find the position vector of the point that divides the line segment QR, or let's say QP. So it means QP, if it was QP, this would have been different. I hope you get this. So just look at how your vector or your question is being given, and you know how to go about it. So this is the formula for the internal division. Let's quickly go through the external division, and we'll be done for this video. In the next video, we'll take examples. Okay. Let two position vectors OP and OQ be given. That is OP and OQ, and then let a third position vector OR divide the line PQ. So this one too is PQ from P to Q externally in the ratio this. Okay, then the following holds. That one too, you go through the diagram, and after the diagram you understand. Okay, so let's say I have my point this. Okay, let me put it here like this. Okay, let me put it here. All right, this is very okay. So it's like this. Yeah, this. Okay, so there's an external other point that divides this in a ratio. So it means that point should be an external point. It shouldn't be part of this. So it means that point is from somewhere here. Let me put it here. Okay, so it's in short dashes like this. This is how the diagram looks like. Okay, this is how the diagram looks like. Okay, it's external division. Okay, so it's like an external part of it. Okay, so with this one we have O to be here as usual, our P is here, and our Q is here this time. That is why I'm saying that there is an external extension of our diagram. Now R is rather this side, okay, but it's dividing the line segment PQ in the ratio M is to N, meaning from P to R is always what? RM. That is what our first said. So from here to here is actually RM, and from this distance to this distance is actually Rn. Okay, so with the external division, this is how the diagrams look like. Okay, now OP is this, OQ is that, OR is that. So PQ goes this way, so it means PR will also go in the same direction. Okay, so this is a scenario, then everything becomes as simple as that. Okay, with this one too, we can say that if you take the vector PR and you divide it by vector, let's say QR, okay, the same thing will happen here. We'll get M over N. Okay, so we'll just go through some of the triangles, and like we first did, we just do what we can do and then get some formulas out. Okay, so from triangle OPR, so we can go back and check OPR. Okay, so let me go and draw that one for you. Okay, OPR looks like this. Let me pick my pencil and draw it. This is how OPR looks like. OP, sorry, PR, okay? And this is small p, if you remember. And this is small r, okay? So this is how the direction goes. We said that we are moving from P to R. So it means that from this triangle, we can say OP plus PR is equal to OR, okay? Meaning PR here is simply, actually, we have done this in our first discussion, that PR is always equal to the position vector of R, small r, minus the position vector of P, which is the small p. I've done this before. That is a line joining 2 points, okay? Alright, so this is PR. Then we go ahead and find for triangle OQR, okay? OQR. That one to go through it and see. Now let's go ahead and check triangle OQR. OQR is from here, OQ then R, like this, okay? That is how it looks like, and the diagram looks like this. From here it looks like this. This one, let me draw it as it is in the diagram, okay? Alright, so this is how it looks like. And with that one too, we have O, Q, then R is here, and this is how the directions look like, okay? This is my R, this is my small q. So it means QR here, I'm just writing it straight away. I know we can go through it. OQ plus QR is equal to OR. So simply QR will be equal to small r minus small q, okay? So this is it for my QR from this triangle. Now with this, let's go ahead and write our formula. We said that PR over QR is equal to M over N. So with this one, PR was given us what? Go ahead and pick it. This is PR, it is R minus P. And QR was given us R minus Q, okay? So we go ahead and bring it inside our formula. So R minus P, this is it, okay? Over R minus Q, small q, should be this over N, okay? Now I have my N into R minus P is equal to M into R minus Q. So I can make R the subject here, okay? Minus NP should be equal to MR minus MQ, okay? Now with this, we can say that NR minus MR should be equal to NP minus MQ, okay? So I have my R out, N minus M should be equal to NP minus MQ. So it means I have R equals NP, okay, minus MQ over N minus M. This is correct, okay? This is very correct for external division. Now, other books will want to simplify this expression in a different way. Okay, so having R to be R is equal to NP in the external division over N minus M. Okay, other books will want to continue this and say that if I factor -1 out in the numerator, I'll get MQ minus NP. Okay, now if I factor -1 out in the denominator, I'll get M minus N, like that, and this will take this out. So I'll get my R to be equal to MQ minus NP over M minus N. So in the standard form, this is how the external division is also given in the standard form, okay? With the internal division, what I wrote was the standard form as well. Okay, so thank you, and just picture these formulas, take them, put them somewhere, and we'll take examples and work with them. All right. Don't forget to subscribe to the